Hello, in this video I'm going to demonstrate the infrastructure monitoring in SigNoz. The infrastructure monitoring module contains two sections, the host and the Kubernetes. Host section has the host infrastructure monitoring and the Kubernetes section has everything related to Kubernetes. The host section has following quick filters. The host name, like that allows you to quickly search the host name and just look at the list of hosts, like the list one or more hosts that you are interested in looking at. And the OS type allows you to quickly filter out the list of operating systems that you are interested in. On the right side, we have a table that has host name, status, CPU usage, memory usage, IO weight, and load average. This table contains the key system performance metrics and the status of the host. If the status is active, it means that the host is reporting the data. If the status is inactive, it could either mean that the host is no longer there or it stopped reporting data for some reason. Here you have a filter section where you can filter by any attributes that are sent along with the host systems. For example, I can just look at the cloud availability zone US Central C, and on applying it shows the list of hosts that just have the availability zone. On the right to the filter section, there is a time range drop down. Here you can look at the all the hosts, like any time range, and look at the hosts that were either continuing to report or reported in the selected duration. Here, after applying it to 3 days, here you can see there are two hosts which have inactive status. There are two which are active status. The inactive status here indicates that the host is no longer reporting. It is no longer reporting either because that host is no longer there or there is some issue. In this specific case, here the host is like the node is no longer there. The Kubernetes management node is no longer there. So that's why its status is inactive. The active inactive is decided based on the whether we have received the any system performance metrics data in the last 15 minutes. That is the listing page. Each host that you see in this list, you can click on it and look at the detailed view of the data. For instance, let me click the second host that I see in the list and go to the detail view. When I click on the host, here you can see that this host has started reporting the data from the February 2nd, 2330, and then still reporting, continuing to report the data. In this metrics tab, you see a very detailed system performance metrics such as CPU usage, memory usage, by state, and the load average over a period of time, network usage, and network usage packets, errors, and all the system disk metrics, disk IO bytes, and the disk IO operations per second, queue size, and the disk operations time. This is a exhaustive list of metrics that are coming from the host reported using the host metrics receiver. The log section here shows you the logs that are applied, logs that are coming from the this host machine. All these logs that you see here are coming from this host. Here you have a time range to select, and here you have a the filters that you can apply to further reduce the search space of these logs that you are seeing here. For instance, I could say body contains message sent, and it will just show me the only those logs that are here. That will allow you to, okay, show me the logs from this host that have the body that contains message sent, which is very useful to drill down. You can change the timeline here, or here you can click on to go to look into the explorer. This will take you to the explorer page where you can do further analysis. Next, we have a traces section which shows you the list of traces that are coming from this host machine. Here you can see the timestamp, the duration of the span, HTTP method, and the status code. You can click on any of these spans and go to the detailed view. Or you can click on the Explorer page here. It will take you to the Explorer and do further analysis. The where clause here works similar to the where clause in the search clause in logs, where you can further reduce the search space, like and list see only the spans that you are interested in. That is about the host monitoring. We have a tabs containers and processes. We don't have it ready yet. We would like to hear your interest in this. Next, let's go to the Kubernetes monitoring. In the Kubernetes monitoring, we have we have number of tabs. Here you can see there is a pods, there is nodes, namespaces, clusters, deployments, jobs, daemon sets, stateful sets, and finally volumes. This is the comprehensive visibility into your Kubernetes infrastructure. Here you can see in the pods listing, the default metrics that are provided are quite comprehensive. Here you can see there's a pod name, CPU request usage percentage, CPU limit usage percentage, the CPU usage used in actual cores, memory request usage percentage, memory limit usage percentage, and the memory usage. As you can see from here, the color coding is also to the point that helps you to quickly find out the resources that are either underutilizing or overutilizing. Here you can see app demo frontend is using 3.8 times more than the CPU request usage percentage and almost 100% to the limit usage. And limit usage, here you can see memory request usage, here you can see it's using 2.1 times. The 213 percentage here shows that it is 2 times more than the what you requested for, and the limit is well within the limit. What this helps you to understand is that the CPU is under provision, like the app demo frontend says that it requires 3x less than the what it should have been configured to. This indicates a problem you want to adjust it. This is a case of under overutilization, which means that you either there is either something wrong with the pod, or it is genuinely overutilized and you need to right size it. Similarly, we can look at the underutilized resources as seen in here. Here, if you see the MongoDB first shard is using the 29% of the request usage and 20% of the limit usage. Memory, it's using 27% of the request usage and the 18% of the limit usage. This is very well within the resource request. However, because it's using the one third of what it is actually needed, it's basically underutilized resources. So you want to right size this as well. So this listing page helps you to highlight those resources that are underutilizing or overutilizing. Let's just go sort by CPU request usage percentage to get all the hosts, all the pods that are overutilizing it. So let's order it by descending order. Here you can see Kafka consumer, Kafka producer, and the app demo frontend. All these pods are overutilizing the resources, and one of these pods even close to the limits, and it will start to experience the throttling soon. This will help you to quickly find out and right size your pod requests and limits. That's very useful to have it, make it such an easy way. Here you have the search class again, which you can say you can filter by any you can filter by any attribute that you may want to. And here you have a group by, you can group by pods in any whatever the dimension that you want to. For instance, let me go ahead and group by namespace name. This will give me a quick visibility into how many namespaces are there and then their CPU request usage and resource usage percentage. Here you can see generator namespace combining all the pods that are present in this namespace. It is still overutilizing 1.5% of the requests. Similarly, memory request has also up. The cube system, on other hand, it's underutilizing the resources. So you can group by slice and dice by any dimensions that you are reporting. So that's about the listing part. Here you have a quick filters on the left side of the pods entity. Here you can say you can go here and just look at the only the pods that are present in here. So here we are looking at a observability namespace pods. I would let's just move to generator. Here we are seeing the pods that are just coming from the generator. So that is the listing part. Let's open one of the pods and look at its detailed metrics. Let us go to Kafka consumer, this pod. Here you can see the CPUs. Here you can see the pod metrics, all the pod metrics that are reported to SigNoz, CPU usage, CPU request, and limit utilization. Here you can see the request utilization is nearly 6 times higher, and the limit utilization is almost close. Similarly, you can see all other metrics, what's the memory usage, and then memory usage, request and utilization, limit utilization percentage, memory usage by state to understand how much of it is cache memory, how much of it is working set and RSS memory, and the breakdown of the pod usage again by the containers in it. Here you can see there's just one container which is using all the CPU, and then the request limit utilization by container. Similarly, the memory request limit utilization and the actual usage by container. So this metrics tab provides you the comprehensive pod metrics. When you go to the logs, you will see all the logs that are coming from the consumer pod. You can further drill down using the search class, or you can change the time range, or you can alternatively explore it in the Logs Explorer for further analysis. When you move to the traces tab, you can see that all the traces that are coming from the consumer pod. Here you can notice that the service name is consumer service 1, and then the pod is also Kafka consumer 1, which matches. So all the this what this means is that this consumer service is running on this Kafka consumer pod and reporting these traces. We can go to the events. This does not have any events, but if pod had any events, they would show up here. That's about the detailed view of the pod. Now let's go to the other entities. Nodes similarly has the similar structure where the table shows the all the important metrics such as usage, allocatable CPU, memory usage, and memory total allocatable. When we go to the deployments, we will see similar. So what's the deployment name available, how many pods are available for the deployment, how many are desired. Similarly, the all the pod deployment wise metrics, request usage percentage, limit usage percentage, actual usage, memory request usage percentage, limit usage percentage, and the actual memory usage. So this is also helpful to have it. Similarly, we have the same for daemon sets, stateful sets, jobs, and volumes. This is all about the Kubernetes infrastructure monitoring.